Again, we continue our lecture on DNA isolation, and we come to part 3. And in this section, we're going to deal with neutralization and phenol extraction. So the learning objectives for this section number 3 is we're going to discuss the principles that underlie the process of neutralization and the process of phenol extraction. Now, in our previous section, we learned that we use the alkaline lysis buffer to lyse the cells and then to expose the lysate. All right, so the second step is we take the lysate and add potassium acetate to it. And the purpose is to acidify the alkaline lysate. Now, this serves a number of purposes. Number one, it renatures the plasmid DNA. And how about the genomic DNA? Well, it doesn't renature that because the genomic DNA is very large and it takes a while for it to come back together. Now, that's why in your isolation process, make sure that you do not shear the genomic DNA, because if you shear the genomic DNA into smaller fragments, those fragments will come together during the neutralization process. Another thing that happens by the addition of sodium acetate is that it precipitates genomic DNA. The sodium will interact with the DNA, potassium will interact with the DNA and neutralize the negative charges on the genomic DNA, and the DNA will fall out of solution. It also interacts with protein to precipitate protein to form potassium dodecyl sulfate precipitates. And you can look at it this way, that when you add the potassium acetate to neutralize the alkaline lysate, it turns from slimy, which is the texture of the alkaline lysate, to snowy, or how should we describe it? Very white snowflakes, as if they're moving around in the solution, and that's the appearance that you need to look at. And then you can just separate all the precipitates out by simple centrifugation. If you use a microcentrifuge tube, you centrifuge it for a few minutes at 13,000 times G. That's the maximum. And then you discard the pellet, and then the supernatant that's been neutralized now is used for the next step. The next step is called phenol extraction. Phenol extraction consists of mixing the neutralized lysate with equal amount of a mixture of phenol, chloroform, and isoamyl alcohol. And the components consist of 25 parts phenol, 24 part chloroform, and 1 part isoamyl alcohol. Now, phenol is used to denature molecules such as proteins and destroy the others such as carbohydrates and lipids as well. Chloroform is added to make phenol to be much heavier so that it can be separated from the aqueous layer, and isoamyl alcohol is added as an anti-foam agent to keep bubble from forming as you rock or you vortex the mixture. This is addition of phenol, chloroform, isoamyl alcohol is followed by gentle rocking for a number of hours. Really, for smaller amounts of lysate, all you do is mix equal amount and then you vortex gently, and then you centrifuge at maximum speed. Again, if it's in a microcentrifuge tube, you centrifuge at 13,000 times G, and then this will separate the the extract into three basic layers. So the top layer consists of the aqueous layer. This is aqueous layer, which contains nucleic acids, that is DNA and RNA, and the interface consists of denatured protein. Okay, there's a band, cloudy band as the interface, which is denatured protein, and then lipids and carbohydrates are in the organic phase, which is on the bottom. Now, we need to talk about the pH of the phenol chloroform isoamyl alcohol. The pH must be maintained at 7 to 8, and here's the reason why. As long as the pH is maintained at 7 to 8, the DNA is going to remain suspended in solution because the pKa, the phosphate groups are not protonated or are not neutralized at pH that is neutral or right above neutral. And so they will be suspended and they will remain in the aqueous phase. And as we said, denatured proteins, carbohydrates, this is accomplished by phenol, and proteins are in the interface, and lipids and carbohydrates are in the organic phase. Now, if you wanted to separate the DNA plus from the RNA, what you do is you make the phenol extraction pH to be lower, to be around 4 to 5. Now, at acidic pH, the DNA will move into the interface. Now, why is that? Well, the reason for that is when you lower the pH, you have gone below the pKa of the DNA. pKa of the DNA is much higher than the pKa of the RNA. So you're going to neutralize the charges on the DNA first before you get to neutralizing the charges on the RNA. Once you neutralize the charges on the DNA, then that DNA falls out of solution and it goes to the interface. And so this is just one thing that you need to keep in mind in case you want to separate the DNA from the RNA. And so the next lecture that we're going to have is part 4, and we're going to talk about now that you have neutralized the lysate, now that you have extracted with the phenol chloroform isoamyl alcohol, then what do you do to purify the DNA?